Day 511 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 611, valid triangle number. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the integer array nums, return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. Okay, y'all, so that sounds pretty simple, but let's take a look at these examples just to make sure that we are doing this problem correctly. Now, before we do this problem or go through these examples, let's make sure we understand how to make a triangle, right? So that's going to be important when solving this problem. So we need to remember that for 3 side lengths to form a triangle, the sum of any 2 sides must be strictly greater than the third side. So what that means is a plus b must be greater than must be greater than c. A plus c must be greater than b, and b plus c must be greater than a. If these requirements are not true, then that means one of the lengths won't be large enough to extend far enough to complete the triangle. So all of these statements or these expressions have to be true for a true triangle to be formed. So now that we know how a triangle will be formed, now let's take a look at these examples. So in example 1, we have our input nums equals an array of integers 2, 2, 3, and 4. Our output is 3 because there are 3 valid combinations that we can create from this array to form a triangle. And the valid combinations are 2, 3, and 4 using the first 2, then 2, 3, and 4 using the second 2, and then 2, 2, and 3 using both of these 2s and 3s and the 3. All of these combinations right here will give us a valid triangle, right? And they fit the requirements. So if we say this is A and this is B, A plus B will be 4, which is greater than C, which in this case is 3. Similarly, if this is A and this is B, we add these together, they'll be greater than 4. So that means we have valid triangles. Similarly, in example 2, our input nums equals an array of integers 4, 2, 3, and 4. This time there are 4 different combinations. We're not going to go through all of them. We're just going to have to trust LeetCode that they are there. And that's why the output is 4, though, because they're able to make 4 different triangles, or they're able to create 4 different combinations of triangle lengths using these elements right here to create a triangle, and there's 4 different ways, so the output is 4. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult at all. First thing we want to do is we want to sort the array so we can apply the triangle inequality efficiently. So the a plus b plus c and a plus b is greater than c, and a plus c is greater than b, and b plus c is greater than a. That's called the triangle inequality. That's what we want to be able to apply efficiently. So that's why we're going to sort the array first. So we are going to say let nums sorted equal nums dot sorted, just like that, and put the parentheses. Then we're going to say let n equal, it should be equal sign, equal nums sorted dot count. Now we need a total number. We need a variable that's going to store the total number of valid triangles. So we could just declare a variable called count and set that equal to 0 to start. And that's going to store our answer or our result at the end. Now we're going to treat num sorted k as the largest side of the triangle, and we're going to start from the end, the largest value, because we sorted it, and move towards the front. So we're going to say for k in stride, open up the parentheses, from, colon, n minus 1, comma, through, colon, 2, comma, by, colon, -1. Then we're going to come outside of that. We're going to open up the brackets. We need a left pointer, so we're going to declare a variable called I, set that equal to 0. Then we need a right pointer, so we're going to say declare a variable called J and set that equal to K minus 1. Boom. Then we're going to use the two-pointer technique to find the pairs I and J, where num sorted of I plus num sorted of J is greater than num sorted of K. So we're going to say while I is less than J, we're going to open up the brackets and we're going to say if nums sorted square bracket I, come outside of that and say plus nums sorted square bracket J is greater than nums sorted square bracket K, then we're going to open up the brackets, and all indices from I through J minus 1 will also satisfy the inequality because the array is sorted. So we're just going to add J minus I to the count. So we're going to say count plus equals J minus I. Boom. Then we need to move the right pointer leftward to check the next possibility. So we'll come underneath that and we'll say J minus equals 1. Boom. Then we could say else. We could come on this if statement right here and say else. Open up the bracket. If the sum is too small, then we need to move the left pointer rightward and increase the sum. So for that, all we have to do is say I plus equals 1. Sorry, plus equals 1. Boom. Now we just need to return the total number of triplets that can form a triangle by coming all the way down here, and we just have to say return count. Boom. Let's run it. See how it runs. Okay, so let's see where we went wrong. Cannot find sorted and count. Oh, stored it. There it is. Now let's run it, see if that works. Let's see, and look at that, y'all. So it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and that's what I'm talking about, y'all. 19 milliseconds beats 76.47% of users. Not too bad at all, y'all. So with that being said, before we go, make sure you get one more look at the code. This is the top part, or this is the whole code right here. So boom, read it, learn it, love it. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.